Hello and welcome to the Chanda Academy. In today's video, we will want to find the domain of definition of a logarithm function. We know that the logarithm is defined when what's inside is greater than 0. But here, the inside could cause us another problem when this thing is equal to 0. To know when the function f is defined, we will want to know when the thing inside of the logarithm is greater than 0 and with x plus 1 different from 0. Okay, let's start. We will first study the function that given x gives x squared minus 3x plus 2. So this is an easy polynomial of second degree. Let's try to find, so let's call it g. Let's try to find the solution to g of x is equal 0. So delta is equal to b squared. So here, minus 3 squared. Minus 3 squared minus 4 times 1 times 2, which is equal to 9 times 9, minus 8. And this is equal to 1. And so the solution will be x1 and x2, because this is greater than 0, or equal to minus 3, so which is equal to 3, plus or minus the square root of delta, which is equal to 1, divided by 2. And we've got x1 that is equal to 3 minus square root of 1, which is 2 over 2, is equal to 1, and x2, which is equal to 3 plus 1 divided by 2 is equal to 2. We have both solutions. Okay, and we know because we've got a positive coefficient on the monom of degree 2 that the solution has this graph. So between 1 and 2, okay, 1 and 2, and going to the infinity before and after those roots, which means that the function is negative inside of the roots. Now we've got what on at the bottom, x, it was minus or plus, x plus 1. So let's study it. So second, let's call it h, that given x gives x plus 1. We've got x plus 1, h of x is equal to 0. Is equivalent, we said it earlier, to x plus 1 is equal to 0, is equivalent to x is equal to minus 1. Before this minus 1, so before minus 1, x is equal to minus 1, we've got h of x that will be negative, and after x is equal to minus 1, h of x will be clearly positive. Given these informations and these informations, we can say that let's call it g, no, let's call it nothing. We know that we will want to sorry to write down a table. So going from minus infinity to plus infinity, here we will have x squared minus 2x plus 2. Okay, that's the first. Minus 3x plus 2. Minus 3x plus 2. The sign of x plus 1. And finally, the sign, and if it's not defined, we are going to tell it to x squared minus 3x plus 2 over x plus 1, which is what's inside of the logarithm. So here we know that something happened in minus 1, something happened in 1, and something happened in 2. We know that in minus 1 we will have x plus 1 that is equal to 0. In 1 it's going to be this polynomial, and here the other polynomial. Now we know that this thing will be not defined if x plus 1 is equal to 0. So in minus 1 this does not exist. Now what happens for the sign? Because we want this thing to be positive as well. We know that this thing is positive outside of the root, so plus, 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 and negative inside. And this thing will be negative before its root and positive after. And knowing that, we just have to do the division. Plus divided by minus is equal to minus. Plus divided by plus is equal to plus, minus, and plus. Which means that our function will be defined. So this thing will be greater than 0 when and equal to 0. So here and here. Okay, and so we want this thing to be strictly greater than 0. And so between -1 and 1 excluded, because in 1 this is equal to 0, and in 2 plus the infinity, because we do not want it to be in 2, because in 2 this will be equal to 0, and we want it to be strictly positive. And so for all, so let's say x squared minus 3x plus 2 over x plus 1 is greater than 0 and exists, is equivalent to x in, let's call it d, which is equal to -1, 1, union 2 plus the infinity. And so we've got f defined, our function with the logarithm, if and only if x squared minus 3x plus 2 over x minus 1 is greater than 0 and if it exists. And so this is equivalent to x in D, which is this set. And so we can conclude by saying, and so the domain of definition of f is equal to D, and it's equal to -1, 1, reunion 2 plus the infinity. And we have solved our exercise. Hope you enjoyed the video. See you soon. Bye.